Hello everyone, this is Sir Tudi. Our topic is about computing the sample size. Okay, so we have two formulas to compute the sample. First formula, n equals the quantity of z sub alpha over 2 times the population standard deviation over d then squared, where population standard deviation is, or the sigma, this is a sigma, where the sigma is the population standard deviation, d is maximum allowable deviation or the margin of error. Okay, we have the second formula to compute the sample size that is called the Sloven formula. So n, the sample, equals the population, capital letter N, over 1 plus n times E over 2. Then E is the error, margin of error. And n, population size, small letter n, sample size, E, margin of error. And this is the solution on how to compute the value of the margin of error. 1 minus the confidence interval. So we assume that the confidence interval is 0.95% or 0.95, and the margin of error is 0.05. Here we have an example. D equals to confidence interval equals 85%, standard deviation equals 10. Okay, using this formula, okay, the first solution, we compute or we solve the alpha over 2. And this is the solution, 1 minus 0.8500, and this is the decimal form of 85%, and alpha is 0.15, and divide both sides by 2, alpha over 2, and then 0.15 over 2, so alpha over 2 equals 0.075. So, z sub alpha over 2 equals 1 minus 0.075, and that is 0.9250. Then break down. So that is 0.500 plus 0.4250. Okay. In the z table, okay, this is the location. So we use this probability. So this is the probability. We use the 0.4252 because there is no exact probability value or probability in a table of 0.4250. That is why we use the nearest of this probability. And this is the nearest probability of 0.4250. Then the z sub alpha of this probability is 1.44, and that is plus minus 1.44. Okay, we substitute to the formula. So z sub alpha over 2, 1.44 times 10 over 5, then squared. By using the calculator, the answer is 51.84, and approximately that is 52. Okay, we have example number 2. Our D is 2, confidence interval 99%, and the standard deviation is 5. Okay, so alpha equals 1 minus 0.9900, and alpha 0.01. Then divide by 2 both sides. So alpha over 2 equals 0.005. Then alpha over 2, 1 minus 0.005. So z sub alpha over 2, 0.9950. Break down. So 0.500 plus 0.4950. Since there is no exact value of 0.4950, and there is a 2 probability with the same distance from 0.4950, and that is 0.4949, and the z-score of this probability is 2.57, and another one is the 0.4951, and the z-score of this probability is 2.58. Okay, so and this is then to compute the z's of alpha over 2, we add these two z-scores. 2.57 plus 2.58 divide 2, and that is equal to 2.577. Okay, we locate or we find this z-score in the z table. Okay, so 0.499. This is the 0.99. Okay, so and the z-score of this probability is 2.5. So that is why we use 2.5, then add the 7. So 2.5, then 7. So this is it. And the z-score of 0.4951 is 2.5. The intersection is 0.08, and that is 2.58. Okay, so then our z sub alpha over 2 is 2.575. Okay, substitute to the formula. So 2.7575 times 5 over 2, then square. Using the calculator, the sample is 41.47, and approximately that is 42. Okay, we have example also of the Sloven formula. Okay, given confidence interval equals 95% and the population is 500, and the margin of error is E minus 0.9500, the decimal form of 95%. So the margin of error is 0.05. So our sample distribute to the formula the population 500, 1 plus 500 times the margin of error, then squared. Then using the calculator, the sample is 222.22, and approximately that is 220.